Hello, everybody. I would like to welcome you to our 11th content webinar. I hope everyone's doing well and progressing actively in the nano degree. I know for a fact that most of you have completed the fourth project, which is the Feed Reader Testing Suite project, which is great. Some of you have even completed the LinkedIn and the GitHub projects, which is even better. Just a quick reminder that the deadlines for these projects is this Sunday. So there are 4 days or three actually away from now. So for those of you that haven't yet completed their projects, don't worry. I mean, there's still time, and if you run into any problems or finding it difficult to implement some kind of feature, I'm here. So constantly, you can ask me whatever it is that you're facing as a problem, and we'll try to work it out together. Also, I wanted to mention that we are almost a month away from the deadline for the last project. So that project is the restaurant reviews app, whose deadline is on the 23rd of June. So there's practically almost 1 month left in the nano degree. So we're nearing completion of the nano degree. So you're about to graduate in about a month from now. It's the 22nd of May. So it's not that much time left. Um, so now's the time to step up and tackle this final project and finally graduate from the nano degree. Um, okay, so with that out of the way, let's talk about today's topic. Today we'll be talking about promises in JavaScript. Promises are a relatively new thing. They were natively supported in browsers only a few years ago. So before that, we had to use polyfills. I'm not sure you're familiar with that. Polyfills is just like transpiling code. So if you're trying to uh, access or use a new feature of the JavaScript language that's not yet supported by browsers, you had to write code that the browser understands, which essentially works like the new feature. So that's how um, you use new features without support in the browsers. So promises are a massive new feature that helps us write code that's more understandable and concise. So it's definitely worth our time to check it out. Also, some of the most common tasks like network requests are accomplished most of the time by promises. So promises are also something that future employers like to ask about in their interviews. So knowing promises will definitely give you a head start in an interview with a prospective employer. Without further ado, let's actually start. I've made a presentation for you again, which I'm going to share after the webinar. There are some resources as well, so let's get going. Let me share the screen. There it is. So, whoops. Um, yeah. So there's the presentation. So now, um, here's our topic, promises. Now, bear in mind that we'll be talking about JavaScript promises. Other programming languages have promises as well as a feature in them. But as we're learning front-end web development, we'll only look at JavaScript promises. So remember that Ruby has promises as well. Python, Java, all of them share this feature, but we'll only talk about JavaScript. This is our agenda. Firstly, as promises are tightly connected to the difference between synchronous and asynchronous code, we're going to explain that. So we're going to explain the difference and see how we can write asynchronous code with the help of promises. After that, we'll start to dive into the world of promises. So initially, we'll first see some definitions of promises to get an idea what they are and know how to reference them in the future. So promises have states, and next, we're going to see the difference. So we're going to see all the different kinds of states as a JavaScript promise can have. Next up, we'll look at the internal properties and methods of a promise. And you know what that means, right? In one of the first webinars that we had in this nano degree, I mentioned that almost everything in JavaScript is an object, and all objects have methods and properties. So if a promise has methods and properties, that must mean that it's an object as well, and actually, indeed, it is. So promises are another example of an object in JavaScript. Next up, we'll take a look at how to create promises. Here you'll see the new keyword in practice, which is used every time we want to create a data type of some sort. So it may be an array, a function, a promise, a closure, whatever. These types of things are invoked with the new keyword. So after that, we'll take a look at probably the most useful thing about promises, and that's the fact that we can chain promises. This means that we can add multiple promises and have them run one after another. You'll see in a minute how beneficial that can be. Just remember that the promise chain is probably the most useful thing about promises. After that, so after we see what the promise chain is, we'll see how promises compare against callbacks and what the callback pyramid of doom is. I know that sounds a bit wacky, so callback pyramid of doom. Trust me, that's one of the worst things as a developer that you can have. So we'll demonstrate what that is, explain it, and talk about why we should avoid it at all times. Next up, we'll look at how we can implement error handling with promises, and then we'll take a look at the browser support for promises. We'll do that because we said that they are a relatively new feature, and all new features have to be taken into consideration. We have to look at the support graphs for all the browsers, and we'll do exactly that. And finally, as always, I've listed a few resources on the web for obtaining a more thorough understanding of these fundamental concepts that we will be addressing in a matter of minutes. So, of course, there are many others out there. Thankfully, promises are a very well documented topic, so you should have no problem with finding the information you need on the web. Okay, so that's our agenda. Let's start. First off, let's make a comparison between synchronous and asynchronous code. Synchronous code is executed by the JavaScript engine line by line in a sequence. So nothing new here. I mean, we mentioned this during a previous webinar. Essentially, what this means is that JavaScript looks at our code and runs it line by line. So if you have, for example, 3 functions, whichever function is called first will run until it executes fully. So if you have some kind of slow function, it doesn't matter. So JavaScript will wait for that function to finish, and only once it's done, it will move on to the next function. And after that, eventually, when the second one finishes, we'll move on to the third one. So it's run line by line in a sequence. This means that there are never two functions running at the same time. This is because JavaScript is single-threaded. Remember, the single thread that JavaScript has is taken up entirely by the piece of code that is currently running. So there is no second or third thread to run some additional code on. This can sometimes be pretty inconvenient because imagine that you have some code that takes a long time to finish, like for example, a network request for a big set of data. So during the time the server takes to respond with the data that we want to have in our application, the other part of the code is essentially stopped and remains stopped until the request is resolved. So this can provide a pretty daunting experience for a user. Imagine you going to a site and that site, when it loads up initially, it sends a request to some kind of remote server, and that request takes a bit of time to resolve. And during all of that time, you're stuck waiting for the request to finish, and you see this blank page, and you're thinking to yourself like, what's going on? Is the site broken or something? And then all of a sudden, the whole site is painted with the response from the server. So that's not an ideal scenario, and that's caused by the fact that the script that contains JavaScript contains only synchronous code. And so that's the essence of synchronous code. And it's useful to know that sometimes it can cause some problems. Asynchronous code, on the other hand, is executed by JavaScript in parallel. This means that we have multiple threads on which our code can run. Remember, synchronous code is run on a single thread. If we write asynchronous code, we can execute multiple functions at once. In terms of our earlier example with the network request, once we send the request over to the server, we don't have to wait for the server to come back with the response. We can keep executing our code while we're expecting that response. This is massively useful because we can provide a more dynamic experience for our users by having multiple threads for our code to run on. So if we have if our app, for example, um, has to load some kind of data from an external server once it is opened up, um, we can send that request over and continue painting our HTML elements so the user can see some kind of data appear immediately and not wonder if the site is broken or not. So that's all provided to us by asynchronous code. So let's go back to a definition that we saw a few webinars ago. Here's the definition that we used in our very first content webinar about JavaScript. So JavaScript is a single-threaded, non-blocking, asynchronous concurrent language. Now remember that this is only a definition of JavaScript. You might be wondering how we can implement concurrency when we have a single thread only. So remember that concurrency semantically means two actions happening at the same time. So that's kind of like asynchronous. So multiple threads, multiple functions running at the same time. This is what concurrency is. So and remember, the runtime is the environment that JavaScript is executed in, the runtime. It's not the engine, the runtime. So the two most common environments in which JavaScript is executed in are the browser and Node.js. So in the scope of the nano degree, we're not so much interested in Node.js, but once you get more comfortable with the concepts, I definitely encourage you to look up JavaScript that's written in Node.js to see what kind of features you have there, what you can do, and what the difference is between JavaScript on the browser and JavaScript in Node.js. Remember that in the browser, we have something called the web APIs. That's where event handlers, network requests, and other specific features live. So um, event handlers are not a part of JavaScript. That's essential to know. They are part of the web APIs, and only because we're running JavaScript in the browser, we can access them. So if we're running JavaScript on Node.js, we can't access them because the web APIs are not accessible via the Node.js command line interface. So remember that we have web APIs. The web APIs are essentially threads that we can run code on. So essentially, they are what makes JavaScript multi-threaded in the browser. Remember, JavaScript itself is not multi-threaded. Like you see here, JavaScript is a single-threaded language. But with the help of the web APIs, we have additional threads that we can run time-consuming code on there and without blocking our script that has JavaScript on it. So that's the difference between synchronous and asynchronous code. Now, you may be wondering, where do promises fit in all of this? Well, promises are our primary way of executing asynchronous code. Let's dive in and see what promises are exactly. Let's have a definition first off. And here's the definition. Now remember, the promise is just an object. Remember that objects have properties and methods. So as an object, promises represent the eventual completion or failure, of course, of an asynchronous operation and its resulting value. There we go. So here we have confirmation that indeed promises are our main tool for executing asynchronous code, so asynchronous operations. At their most basic, promises are a bit like event listeners, except that a promise can only succeed or fail once. Remember that once we attach an event listener and pass some kind of callback to it, that callback is run every single time the specific event occurs. So if you place a click event handler on some kind of HTML element, whatever you pass as a callback to that click event handler will run every single time that this click occurs. So unlike that, promises cannot succeed or fail twice. Neither can it switch from success to failure or vice versa. If a promise has succeeded or failed, and you later access uh, a promise, and the correct callback will be called even though the event took place earlier. So this is extremely useful for async success or failure because you're less interested in the exact time something became available and more interested in reacting to the outcome. So once we construct a promise and pass in the success and failure callbacks, we're not allowed, or actually we're not interested in when exactly that promise will resolve. We're more interested in what is going to happen when the outcome is ready. So here, with the use of promises, we just determine what will happen when the code resolves. So when the code completes, we're not worried, or we don't have to worry about when exactly this will happen. This is another definition I found online and thought that it could be useful in obtaining a better understanding of what promises are. So here again, we have confirmation that indeed the promise is an object. So it's special actually. Also, we understand that a promise is a link between the producing code and the consuming code. Here we should explain what producing and consuming code are. I mean, they're pretty self-explanatory, but for the sake of clarity, let's have a bit of a discussion for that. The producing code does something that takes time. For instance, the code could be loading some kind of script, like in our earlier example, it could be sending a network request and waiting for a response, and all types of time-consuming things. It could be a set timeout function, whatever. So in the meantime that the producing code is executing, the consuming code is waiting for the producing code to finish because its execution, so the execution of the consuming code, depends on some part of the producing code. In our example, maybe the script contains some variable or some function that the consuming code needs. So if we're sending some kind of or requesting some kind of variable or data from an external server, um, that's the job of our producing code. That's where the request happens, and we wait for the response from the server. And once that becomes available, the producing code um, hands that to the promise. So the promise now has the result of the producing code. And once it gets that result, it passes it off to the consuming code. So what links these two, the producing and the consuming code, is the promise. Um, the promise also allows the producing code to take all the time it needs to produce the promise result and make it available to all of the subscribed code, which is essentially the consuming code. So with the use of promise, we actually make a verbal promise to the consuming code that some kind of producing code is going to produce the value it needs. So remember that we said that we don't have to worry about when the producing code will um, have the value available. That's because we're using promises. So that's what's really useful about them. So a promise has two things that are called states and fates, which are very typical to it. So there's no other data type in JavaScript that has a state and a fate. So um, once you start using promises, um, making a difference between states and fates is very confusing at first. The promise evangelists in the JavaScript world really look down on you if you get it mixed up. So um, in a minute, we're gonna see exactly what states and fates the promise has. And I think you'll be very confused at first, but if you stick with it, you'll get an intuitive sense for what is what. So a promise has two things called states and fates, as we saw. Um, a promise can be in one of these three states listed here. A promise always starts out as pending. This means that the promise is neither fulfilled or rejected. This is the situation when the producing code is not yet ready with the outcome and the consuming code is still waiting. So in our example, when the promise is pending, we are performing the network request and waiting for the scripts to get served to us. Um, Once a promise is not pending anymore, so in our example, the code from the server has come back and we have it ready. The promise has become one of two states. It becomes either fulfilled or rejected. If the promise is fulfilled, the producing code took its time and it successfully returned the value of whatever operation it performed. So um, our producing code successfully fetched the data from the remote server. The consuming code can now take that outcome and do its thing. If, however, the promise is rejected, so this is the final state, rejected, this means that the producing code has failed to execute for some reason, and the promise gives the consuming code an error, which ideally, so the best case scenario is that whatever is returned by the promise describes the reason why the producing code has failed, which is not always the case, but generally it is. So when a promise is rejected, the promise, the executing code in the promise, when it is pending, has run into some kind of error. So in our example, if we're sending off a network request to a remote server, we might be requesting data that is not on that server, or our internet connectivity might be slow and it takes too much time, or the server might be down. In each of these cases, our promise gets rejected and the consuming code um, gets some kind of error. And essentially, we're stuck with that. So there's nothing we can do. And these are the three states a promise can be in. Remember that once a promise enters a certain state, it can never be changed unless it's pending. Um, Once a promise goes from pending to fulfilled, it can never go back to pending again. Also, it can never go from fulfilled to rejected or vice versa. Once a promise is not pending anymore, that's it. So the promise can be visualized as completely removed. We can't do anything with it anymore. All right, so we talked about the states of a promise. Now let's see the fates of a promise. A promise has two fates, resolved or unresolved. These two are mutually exclusive as well. Remember, we said that a promise cannot be rejected and then go to fulfilled. So, uh, in similar terms, a promise cannot go from unresolved to resolved, or vice versa. A promise is resolved if trying to resolve or reject it has no effect. So this means that the promise has already given the results of the producing code to the consuming code. On the other hand, a promise is unresolved if the consuming code is still waiting for the producing code to finish executing. So remember that if a promise is unresolved, this means that the state of the promise is pending, so it's not yet fulfilled or rejected. And if a promise is resolved, it can be rejected or fulfilled. These are the two fates of a promise. Of course, once the fate of a promise is resolved, it can never go back to unresolved again. Um, a promise initially starts out as unresolved because if we try to resolve or reject it, it will have some kind of impact. So that's essential to learn. Now, let's take a look at the methods and the properties of the promise object. A promise object has only two properties. They are the state and the result. The state property is pretty self-explanatory. Um, as you noticed, we took a look at the three states, and if we access the state property, it will tell us what the state of the promise is at the time that we're accessing the state property of the promise. Um, and essentially, the three values that we can expect from the state property are pending, rejected, and fulfilled. Um, the result property, on the other hand, is an arbitrary value of our choosing. So we can set it to whatever we want, and if we don't set it, it will be undefined. And that's essentially all there is to the internal properties of a promise. Um, Most of the time, we'll not be making use of these two. We'll only be making use of the methods, as you'll see in a bit. So here are most of the promises methods. Actually, they're about all of the methods. One of them is we're gonna take a look at one of them in more detail, and that's the catch method. Um, it has to do with error handling, which I've separated it into a separate topic because I think it's noteworthy. So um, first up, we have the resolve method. This method returns a promise object that is resolved with a given value. If the value is a promise, that promise is returned. So if the value is a denable, and notice here that we have a denable is just a data type that has a .then method. So an object that has to have a then method. If it has a then method, we can call it a denable. Okay, so if the value is a denable, the return promise will follow that denable, adopting its eventual state. Otherwise, the return promise will be fulfilled with the value. This function flattens nested layers of promise-like objects into a single layer. So we can use the resolve method to flatten out multiple chain promises. The reject method simply returns a promise object that is rejected with a given reason. The good thing about promises is that we always get returned something, and in this case, we have a reason. So we know most of the time if we construct our promises appropriately, we will always have a reason for the rejection of our promise. That reason can take the form of some message, error object, or anything else. Most of the time, it will be some kind of error objects that we have predefined. So the next method, the then method, is part of the prototype of the promise object. Actually, all of the then, the catch, and the finally methods are parts of the prototype of the promise object. Um, the then method returns a promise that takes in two arguments, as you can see, which are callback functions. The first one, so the success, as I've named it here, is called whenever an object is fulfilled. So remember, fulfilled is the state that a promise is in if it's successful. And the second one, the failure callback, is run if the promise is rejected. The next method, the catch method, deals with the rejected cases only. So we must always provide a function that will run in the case that the promise is rejected. We do that because it will be easier to know the reason for the rejecting our promise if we have a catch method with a function defined. Actually, the catch method is kind of a sugar-coated then method that has the same function passed as the success and the failure callback. If you have the same function as both the success and the failure callbacks of a then method, the same function will run regardless of the outcome of the promise. But it's common to use the catch method instead. Also, if you have a then function that has its first argument, so the success callback, as you can see here, if the success callback is set to undefined, for example, and we only have a function for the failure callback, um, that's another way that we can use a then function instead of a catch and have the same functionality. But that doesn't make any sense, so you're better off using the catch method, and it's what everybody uses. The finally method is also part of the promise object's prototype, as you can see. Well, you can't see, but I just said it. So it also returns a promise, and we must also provide it with a callback that runs regardless of the state of the promise as long as it's not pending. So if the promise is pending, it has a state of pending, the finally function will not run. It can be either fulfilled or rejected, and the callback inside of the finally method is always run. So whatever the outcome of the promise is, whether it completes successfully or has failed for some reason, the function that we pass inside of the finally method will always run. So here we are not interested in the outcome of the promise. We just specify what will happen when the promise has stopped executing. The next method, so the all method, is kind of specific. We must pass it an iterable. An iterable means some kind of data type that we can loop over. So in most cases, an array. Um, and this iterable, so the array, has to have promises in it. So if we have some kind of array with promises in it, we can use the all method. The all method will attempt to resolve all of the promises inside of the iterable, and once all of them are successfully resolved, it returns a single promise with the value. If, however, one of the promises is rejected, the all method stops them all and returns the error of the first promise that has rejected. So here, depending on the success of all of the promises inside the array of promises, um, the all methods will return different things. So even if a single one of, let's say, 100 promises fails, the promise that we will get from the all method will have the error in it. So all of the promises must be successfully fulfilled. The race method, finally, the race method also expects an iterable full of promises. The difference is that it only waits for whichever promise is resolved first to get uh, its outcome returned. So um, what's specific for the race method is that we have an iterable full of promises, and the first one of these promises to get resolved in some kind of way, so it may fail or may complete successfully, uh, that value is going to get returned. All of the other promises are stopped and disregarded. only the one that completes first will get its results as a promise. And that's pretty much it for the promises methods. Now that we know all of these properties and methods of the promise object, let's actually see what promises are like in practice. Here is the blueprint we will always use when we're trying to create a promise. More or less, all of the promises that have ever been created look like this when you abstract all the functionality. So in the first, in the my first promise variable here, we create a new instance of the promise constructor function, which returns a promise object. Remember that we said that we invoke a constructor function with the new keyword. As you can see here, the new keyword. We use new, we add a space, and then invoke the promise constructor function. Inside of the constructor function, we pass in an arrow function. Notice the arrow function. This is the S6. Hopefully you know by now what the arrow function does. And this arrow function returns a promise object. You'll notice here, a filled or rejected. Inside of the constructor function, so in here, is passed an arrow function. This arrow function is called an executor. Look at this. This is the resolve and reject. This is what we pass as arguments to the arrow function. And inside of here is the executor function. The executor function accepts two arguments, as we said, resolve and reject. These are two of the functions we saw earlier, and now we know what they do. So when we run the promise, the executor function goes to work here. So this is the part where some kind of asynchronous code runs. So maybe here we dispatch request to an API or a server or whatever, and perform the needed operations. And once those operations finish, based on the success of the outcome, it calls either resolve or reject. So either resolve or reject, not it. Both of them can be called at once. So you already know that resolve is for the successful code, and reject is for the code that has produced some kind of error. Now remember that this is just the blueprint for a promise. This is the distilled down version of every promise. So usually promises have a lot of code in them, which is most of the time hard to understand. So this is only a blueprint. This is not valid code. So we are not calling these two functions here or even one of them. Notice the comments here. This is just a promise. It doesn't do anything. So let's have an example of a real promise. This is a very basic example of creating a promise. Notice how we're storing our created promise in a variable again. Inside the promise, we have the executor function that takes in resolve and reject. So more or less, you'll be writing this every single time. Notice how this time this is a plain function and not an arrow function. Using arrow functions inside of promises is a kind of an advanced technique, and if you don't feel comfortable with it up until now, don't worry. If you get some more practice with normal functions, I'm sure you'll start using arrow functions as well. Inside the promise, we have the executor function, this one, the normal function that we talked about now, that takes in resolve and reject. In the executor, we run a set timeout function. which, as you know, always executes correctly. And that's why in this promise, we only have the resolve function called, and the reject is omitted. So if we have a reject function, it will never get called because uh, there is nothing that can prevent the set timeout function from running. So there's really no use in calling and having a reject function here. Only the resolve function is going to get called in any time. After the set timeout finishes, so after 300 milliseconds, uh, we have put the then method on the promise, so right here, um, and inside it, we receive the value of foo from the resolved promise. So notice here that the promise resolves with the foo string. So whatever we put in resolve is going to get passed to this then method here. And notice that here, uh, the then method has a callback, an anonymous function that receives a value of some kind. This value here is equivalent to this. So we pass foo to then, and immediately we have access to it right here. So when this callback function executes, we console log the value, so whatever you get from the first promise, and in this situation, it's going to be foo. So if we console log the promise, however, we will see the promise object. So feel free to um, run this code in your own browsers to see what happens. And that's pretty much how we can create a simple promise. Of course, we should create much more complex promises than this one for them to be actually useful to us. I mean, but this example is helpful in understanding the basics. So whenever you feel overwhelmed by some kind of promise, you can go back to the blueprint and this basic example to maybe make a bit more sense of what's going on. So now let's see probably the most useful feature of promises, and that's chaining. Promise chaining has all to do with the then method we saw earlier. Remember that we used it to get the result of the resolve promise in our last example. So if we go back a few slides, right here, we use the then method. Uh, the then method accepts promises and can return promises as well. So um, this means that we can use multiple thens to create a chain of promises which runs every time a promise is resolved. This means that we can take some kind of value and manipulate them in some kind of way to make them more useful or perform some kind of additional task based on this value once they become available. So once a promise is resolved and we pass on the value to the next promise using the dot then method, we can perform some additional kind of manipulation on that specific value and then pass it on to the next function or use it if we have completed all the manipulations we want on it. So now that this is a graphical illustration of the process of chaining. Here we see how the initial promise flows into the then method or the catch methods, which perform some kind of operations depending on the outcome and then return the results, which flows into another promise again that produces some kind of result, which is obtained by the next set of then or catch methods, depending on the success of the code in the executor function. This is essentially what happens when we construct a promise chain. These types of chains can be infinite. We can have as many promises, we can have as many thens and catches as we want. We can also nest them, but um, I really discourage you to use nesting of promises, because that can lead to bad practice, which is the callback pyramid of doom. So be careful with that. So here's an example of promise chaining in terms of code. The whole idea of what we're doing when chaining promises is that we're passing a result through a series of then handlers. The initial promise resolves here in 1 second with the set timeout. 1,000 milliseconds is 1 second. Um, and once the promise is resolved, the second then handler is called. So right here, it alerts the result of the first promise that's obtained, which is 1. Remember, we have result 1 here, and then modifies this result uh, by adding 1 to it. So, or actually multiplying it by 2, and we receive 2, which is passed off to the next then. So the next then method. This process is repeated again and again. We always alert the result and some kind of modify the outcome of the previous promise in some kind of way. In this specific situation, we always multiply the number by 2. And here's another graphic representation of the promise, of the process of these promise chaining techniques. So we have a promise that resolves, and then we pass it to a then handler, and then that gets passed to another then, and another then, and so on and so forth. This can seem a bit daunting, but once you get to grips with it, you can dramatically increase your code quality with these promise chains. Now let's see what the world was like before we had promises at our disposal. Before, when we had to execute some kind of asynchronous operation, we would use callback functions. Callbacks, as you probably know, are functions that we pass into other functions. Once the main function executes completely, it calls the callback that we have provided. Now that's plain simple enough for 1 or 2 operations, but if we have some kind of multi-step process in which the code in every single step depends on the code in the previous step, we would end up having to nest callbacks inside of callbacks inside of callbacks, which would end up in the callback pyramid of doom. Here we can see an example of how a series of callbacks produces the pyramid of doom. So notice how we have this triangular shape here of the code. This is some kind of like pyramid, and it's called the callback pyramid of doom. Notice how the do third thing function here is nested 3 levels deep. This is not good for readability. Also, the second and actually the most prominent problem with this code is that we have to pass the failure callback function, this one, um, inside of each and every function to be sure that we will catch a potential error and prevent the code from breaking our app. These are a number of headaches that we could potentially avoid using promises. Notice that here on the right side, we have code that is doing the exact same thing, but is very shorter and much more concise. In addition to this, we handle errors like we do in the left example, but only by using a single catch statement right here. So we're only having to pass this failure callback at the end in the catch statement. This is very convenient and much more legible than the callback pyramid of doom, and it does essentially the exact same thing. We saw in the previous example that we can handle errors in our code with promises. So let's talk a bit more about this. Um, well, as you saw previously, we handle rejected promises with the catch method. It accepts a callback function which is run if the promise is rejected. As we mentioned previously, using catch is the same as having the same function passed as the success and the failure callbacks of the then method, or having undefined as the first argument to the then method. We simply use it for introducing a bit more clarity in our code, so improving the way our code looks and making it a bit more readable. The first promise in the promise chain can reject, and the catch method will still catch it. So no matter where in the promise chain an error occurs in the executor function of the respective promise, the catch method will always catch that. So if we have some kind of promise chain that has nested promises, a catch method will only catch the promise that has failed inside of the specific context. So the nested catch will only look at the promises that are nested. If the error happens in a promise that's outside of this specific nesting level, it won't catch that. So we must provide a catch statement for each and every level of nesting that we introduce in our uh, promises chain. So the good thing about the catch statement is that it catches errors wherever they occur in the promise chain. But as we said, we should be especially careful with nested promise chains. We mentioned that promises are a relatively new feature of JavaScript, and as such, we should keep in mind that the support for it in the browsers we're going to aim our project at has to be taken into consideration. So, whenever you're thinking of a feature or some kind of CSS property or some kind of HTML element, I would definitely advise you to go online. And if you're not sure if this specific feature or element or property, like I said, is supported in the modern browsers, you should definitely go online in some of the websites like MDN or caniuse.com and do some research and see if the versions of the most popular browsers support that feature. So the good news is that the browser developers have been hard at work in integrating promises into pretty much all the modern browsers, which means that we can freely use them pretty much everywhere. So we should keep in mind, however, that there is an issue for some versions of the Edge mobile browser here, as you can see, um, and the Samsung Internet browser. Some versions of those do not support the finally method. So if we want to use the finally method on these specific versions of the browsers, we have to provide a polyfill. So um, you can search online for polyfills for promises. They have been around for quite some time now, so you have no problem with getting those at your disposal. Notice how there is no support for promises in Internet Explorer. If you're not up to speed with the modern browsers nowadays, Internet Explorer is no longer considered or supported by Microsoft. So the versions that um, are coming out for Internet Explorer are not going to be modernized in any way. So um, the new features won't be available to us in Internet Explorer. So Microsoft has moved on to Edge, and thankfully for that we have support in pretty much everything. So, and we have a few resources. These are the ones I use to prepare the webinar with. As I said, there's pretty much there's a lot of information out there on promises, and I definitely urge you to check that out. And of course, if you have any questions, you can find me on Slack. And that's pretty much it for the presentation, and for the webinar as well. I mean, I wish you all the best with the projects. I'll be here if you need me at any time. And good luck. And that's it for me. So have a nice evening and bye.